In North America, actually, stroke is the leading cause of adult disability. And usually that form of disability is weakness in the upper limbs. Typically, it's going to be one half of their body will be paralyzed completely. So they won't have any use of one of their arms. One way people try to circumvent that is to investigate new methods of rehabilitation, especially for stroke patients with upper limb motor deficits. Our project was focused on incorporating a brain-computer interface into functional electrical stimulation to rehabilitate the affected limb in stroke patients. So the way we went about doing that was getting healthy subjects to do all different types of hand grasp while we recorded electroencephalography, or EEG, and then we analyzed that signal rigorously until we found something that we could use as a control signal, which we could potentially interface with simulation. For me, most of my time in art school was made troubleshooting different things and building a bunch of weird sculptures and sort of interfacing with electronics I didn't know how to use and stuff like that. That sort of ability to problem solve or troubleshoot has been incredibly helpful, not only during this project, but just as my whole career as an engineer has been amazing. And I at first thought the two were so different, and so did everybody else, but it actually turned out they complement each other pretty well. Because you have to seat the patient in a scenario that they're going to engage with. So it's not just about designing boring experiments and collecting data and making a guess at what might work. You really need to engage the patient. There's a really interesting link with sort of making things fun. You'll see a lot of virtual reality environments designed for stroke patients because they engage with it a bit more. And that's going to be the key to at least the first few steps of rehabilitation.